So in that case, let's start with the Fusion 360 API. What's new? So basically, we just went back, looking at what happened during the last year, what sort of new functionalities have been added. It's a bit strange that I'm presenting while Brian is online, but he knows much more about it than I do. But anyway, so one of the big additions, at least from my point of view, is the addition of custom palettes. So now you will be able to create your own palette in the user interface and then use HTML syntax in it, to create your own user interface. And you also have the ability to hook it up with your JavaScript code. So obviously it can be used as a proper user interface inside Fusion, and then it's basically, because it's based on HTML, it's fully customizable. So you can add whatever you need. And there will be some more functionality related to that on the next slide. But a couple of other things which were added, like sketches.add without edges. So previously, by default, when you were adding new sketches, it automatically created the projected edges inside the sketch. And it might be sort of confusing for people because, you're using the API in order to automate things. So you tend to want to be in control of what exactly is happening. So when you're creating a new sketch, if you want some of those edges, then you can add them yourself. It does not have to happen automatically. And on the mouse event arguments, now we have a viewport and viewport position. So now when tracking the mouse movements, you will be able to get the viewport position of it as well. Then we also have functionality to load and unload custom material libraries. And here comes the part which is sort of related to the custom palette, which was added. Because by default, when you're creating your command, the command functionality behaves in such a way that first, obviously, you have to provide the various inputs that your command will require from the user. And if you provided those parameters, then a command dialog will pop up requesting those inputs from the user. And then once the user clicks OK, then the command would be executing. If you're not providing any of these input parameters that you want to get from the user, in that case, the command would just automatically execute and it would be finished. So in order to be able to use the custom palettes as well, we added these extra functionalities, the do execute preview is auto execute, so that you're in control of how the command flow is going. So you can start the command itself. You can bring up your own custom palette if that's what you want to do, then gather the inputs from the user in your own way, and then you can call do execute preview when you're ready to do that. And in order to take advantage of it, first you have to set the is auto execute parameter to false, so that the command wouldn't just execute and finish straight away as you start running it. Some additional inputs is like inside the string value command input is value error, so you can set if the specific value is accepted in your view, is a valid input or not. And on the viewport object, we have something called view to screen and screen to view. Again, this enables you to interact better with the mouse tracking inside the user interface. So if you're using, for example, the built-in functionalities provided by the operating system, then you can easily just translate the positions into the view position. And there are quite a few document-related events that now you can, from May onwards, you could subscribe to: document activating, document activated, document closing, and the rest, document saving, and so forth. So basically, whenever something document-related is happening, the user is opening a new document or switching between the documents, then now your application can react to these events. And on the palette side, we added set minimum size and set maximum size. It's quite obvious what they do. And in import options, now we have an is view fit property that you can also set by default. It's true. That's how everything is done by default. And on the Python side, we also upgraded the version of Python that we were using inside Fusion 360. So unless you're compiling, or unless you're running compiled Python code, you don't have to really care about this, because the latest version, whatever version of Python Fusion is using, will be used to compile your code. And in the June release, we've been tracking the usage of the various APIs, and we've seen that JavaScript wasn't used as much as the other two. So therefore, we decided, to be a bit better with the resources, that the JavaScript part would be going into maintenance. The only thing it means, what it really meant, is that the documentation would be removed from our website, but your existing code will still, run inside Fusion. If you already have a JavaScript code, a JavaScript add-in or script, that will still run inside Fusion. And the new functionality is user-specified program path. So now inside the user interface, the users, including you can set the default path for scripts and add-ins, where Fusion will be looking for scripts and add-ins, and also where the newly created scripts and add-ins would be saved. And change in adding script or add-in. So from now on, you will be able to select the actual folder where the script resides, instead of having to select the script itself, whether it's a Python script or JavaScript or something else. Now you can just select the folder itself, and then Fusion will automatically fetch the relevant script file from the folder. We also added support for copying or cutting and pasting a body, and also external references related functionalities have been added in the API. And then another thing is, now you can also write to the text commands palette. I'm not sure if every one of you are actually familiar with this, but in certain cases it can be quite useful to just open up the text commands palette inside Fusion 360, where you can type additional things. I might as well show it to you. I had it somewhere here. So Fusion here. So basically, if you go into this file menu, then you can see the view. Then you can say show text commands. So this is what it looks like. I already started playing with it. So just like in case of editing your Python code in the editor, you can also add them directly here. As you can see in the bottom right corner, you can set the language which would be used. So in this case, I'm using Python, and then you can run here the same sort of functions inside Fusion, like importing the certain libraries from Fusion, then declaring various variables, and then assigning values to them, and so forth. So for example, here I just went through a couple of things. I declared the app variable, the UI, and then access this text commands palette, where I could also write the message. And as you can see, as soon as this write text executed, that was already written into this text commands palette. And then, so basically, this is just one more thing you can take advantage of when developing your own scripts or add-ins. Another new functionality is intersect model with sketch plane. And some new things in the September release, allowing users to select a folder. And then now we are enforcing unit vectors in case of matrices. So previously you could just pass in whatever, and then Fusion automatically assumed that it would be a unit vector. But now we are enforcing it as well. So if it's not a unit vector, then you will get an error when trying to use a matrix, such a matrix. And then from then onwards, you can also get back the bounding box for vref edge. And we also have a new version of import to target, which is called import to target 2. In this case, it will return all the objects which were created as a result of calling this function, which is quite useful, because in that case, you know exactly what has been added to the Fusion database, and then you can act based on that. And a couple of new things. One is related to occurrence, where you can now use the break link function. And in case of Sketch, you can use the project to surface functionality. Yeah, and I showed it in Capital's custom graphics in the 2nd September release. I think it's quite a powerful addition to the API, and many developers were asking about it. And fortunately, there's also a demo inside the documentation, inside the online documentation that you can use. So you might as well run it. Show what it looks like. So if I go to custom graphics, so here you can see a cool dialog which enables you to set, what the custom graphics object should be like. It's a mesh or lines or point set or the rest. You can also play with the color, and you can see the results straight away. You can also interact with it in the user interface, move it around if you want to. And also some special handlings are enabled as well, like view placement. You can specify if it should be stuck at a certain position in the UI. You can set it if it should be upper left corner or upper right corner, and so on. You can also play with the scaling, how big the object should be, and it will keep that size all along inside the user interface. Then beer boarding, if you want to keep the position, always facing top inside the user interface, or you want it to rotate as the user is rotating around things. So in this case, for example, if I go on orbit, as you can see, it's sort of orbiting with the rest of the user interface. So it's quite a cool sample, so it's definitely worth having a look at it if this is something you're interested in. And then I think this should, showcase most of the functionality which is available. Another thing which was added is component, body, and Sketch now has something called the revision ID. So if you want to track the changes inside the Fusion document, then it's really helpful for you. Because each of these objects have the revision ID, you can check if you can store the revision ID of a given component or body or Sketch somewhere in your own database, or maybe inside an attribute in Fusion 360, and later you can check if you need to regenerate something because the revision ID changed, which means that something has been changed inside those objects. Or if the revision ID is the same, then you don't have to do anything, everything is up to date as it should be. And then the CAM version, on the CAM side of things, now we have something called the machining time, which provides access to machining time related information. And in the November release, we added something called the Measure Manager. So if you're familiar with Inventor there as well, that these measure utility tools is similar to that. So it enables you to easily check distances between points and objects and lines and so on. I will show a demo for that as well, which is part of the online help. We also added something called temporary VREPs. So without adding anything, any VREPs or solids to the actual Fusion database, you can just create these objects in the background and do some operations between them, and then check the results if that's what you need. In case of sweep, we have now twist and taper angle options, and on the application we also have now a new event called the camera changed event that your heading can listen to. So the measure manager, I show the sample for that as well. So in this case, you can have a look at this. It's quite easy to find all this on the inside. Basically, you can see how it's created an object inside the user interface. this solid box, and then it's checking the distances and other measurements of this box using the API, and then just lists all the information inside the console of the debugging environment. In this case, it's the Python environment. So you can see all the things that we measured: position between the 2 points, or angle between points, or bounding box of the various objects, and so on. Yep, so that's pretty much all I had for the Fusion section. Does anyone have any questions? Oh, I can see Andy is back, so I hope he has his voice back as well. Any questions from anyone? You can just type it in the questions part, so everyone should have in the user interface something called the questions tab. So if you have any questions, just please type it in there, and then we can get back to you. Also, do take advantage of Brian being online. So. Anyone? So is there any support for the sculpt environment? Oh, I did not check it last time. Can I unmute? Well, I'm just unmuting Brian. Brian, I unmuted you, so don't be surprised. Do you know the answer to that?
Which environment?
The sculpt. I don't know off the top of my head if there was already something for that.
I still didn't understand which environment.
Sculpting.
Oh, no, there's nothing.
Okay, another question. Can we measure the minimal distance between two bodies or components?
I think that new measure capability has it, that you just demonstrated.
Yeah, so Vladimir, you can just have a look at the API, so hopefully it is there. Okay, so any other questions? If no, then let's continue with the design automation for Inventor. And just to repeat it again in case I don't think anyone new joined actually, but just to make sure. So the next presentation will be the design automation for Inventor, and then there will be a separate webinar coming soon in about half an hour's time, which is only for ADM members, unfortunately, in case you're not one of them, because it's related to desktop products, and looks like we still can't talk about it in public just yet. Okay, so it's back to Andy in that case. So I'm just making you presenter.
Thanks, Adam. So how far did we get last time? Did we make it into the presentation at all?
Yeah, just the very first slide about the safe harbor. That's how far.
Did you get the disclaimer?
Yeah, that's it.
That was it. Okay.
Yeah.
Sorry about that. All right. So can you see my screen all right?
At the moment, yes.
At the moment, all right. So let's dive into this. For me, this will be again. For hopefully some of you, this will be new. I really want to cover.
Probably the font is a little bit bigger. I believe the PPT is not shown properly.
Is it not showing?
Yeah, agenda A is cutting out a little bit, at least at my end.
It might be just yes, cropping your screen or something.
Do you see it okay, Adam?
I can see your whole screen, but when you go to presentation mode, then it seems to be cropping the presentation. So half of A is missing of the agenda, for example.
Okay, let me try something here.
Maybe you just have a huge resolution or something.
It could be. Yeah, I'm on a surface here. How bad is that?
Yeah, that's perfect.
That's perfect.
Okay. Okay, so I want to go over just introducing what V3 is for design automation. For some of you that aren't familiar, we'll go do an overview of what design automation is, and then I'll jump into where we are with design automation for Inventor, what that looks like today, and a few things of what's coming. Just make sure. Just checking again, Adam, you can see this all right?
Yeah. I will let you know if I can't see something.
Okay. Okay, great, thank you. So really wanted to just do a little bit of an overview of design automation. So really this is all about leveraging the scale of Autodesk Cloud to automate your workflows. And specifically this was started with AutoCAD and the idea of AutoCAD I/O, which eventually became the design automation API in Forge. And this is all about processing Twig files with engines in the cloud so that you'd give it an input, run it through some scripts, and be able to generate some output, right? So if we look into what version 2, which is what we have there today, is doing, it's really a simple Twig processing service where you give it input URLs, you give it where to put the outputs, and you run some AutoCAD commands. So for Inventor, this is really similar. You give it some input URLs, the output URLs, and you upload an Inventor plugin, which is basically an Inventor add-in without any of the UI, right? So there's clearly some benefits here where you don't have to manage the licensing or hardware. We're looking at how many versions of Inventor we want to support up in design automation. AutoCAD I/O has been available since November 2014, so it's been around a while, and it's published millions of Twigs already. So there's an existing platform for automating desktop workflows in the cloud that we're leveraging now for Inventor. We're currently in V2 with a private beta with a couple customers to help prove it out. And I'll talk about as we move forward with V3 what that looks like. So if we just look at the overall workflow for design automation, for those of you who are unfamiliar, you make your data available in the cloud, put that in some kind of cloud storage. You give the worker links so that the worker can actually access your input files. We download those input files onto the worker. We then upload those results back via links. And then once that worker's done, we're actually done with your data. We don't hold on to it at all. Right, so if I look at what that API would look like, there's basically 4 main endpoints in design automation today. So this is what the V3 endpoints look like. If we map those to programming concepts, work items are similar to a function call. Activities are that function definition or what that interface is going to look like into your app. And that app could be considered like a shared library. And the engine you can think of as a CPU instruction set. That's where the actual work gets done. So if we map that to a product concept, the work items are really the product execution. You can think of that as the session or the job. The activities are, again, those parameters you're going to hand into the app. So it could be something like a script file, something like command line parameters. And then the app itself is your Inventor plugin. Right. If we look at the engine today, this would be for Inventor. This would be Inventor Server. For V2, this maps to really similar names, but we did clean up a few things. We made a more standard API from a lowercase standpoint, and then the biggest change is we changed the apps we changed what used to be called app packages to just apps now. So if we look at these in a little more detail. Right, activities are stored and reusable. Similar with apps, they are created once or updated a few times, but they're used over and over and over. Apps can also contain content. So if you're looking at something like a configuration app, those could be template files that are used to generate the output. And then the engines are the actual desktop server engines that we host up in Forge to automate the workflows. So if we look behind the scenes, the worker receives that work item. The work items go into a queue, and we have a pool of workers that will pull those items off the queue based on what version of Inventor you want to run. It will run the job on the worker that's capable of running that version of Inventor. We'll download the input arguments, via HTTP GET. We'll pull your files onto that worker. We'll run Inventor Server. We'll run that in a sandbox environment, meaning you can't reach outside the sandbox or the temporary workspace that we give you to run. We then send those results back to your cloud storage via HTTP post or put. So if we look at some of the new V3 features that are coming, we've simplified the JSON payloads quite a bit. So if you have experience with V2, I'll have some more details I can share later on this, but basically some of the benefits we have are being able to do not just clean up the JSON, but also be able to expand some variables so that it makes it easier to work with whether it's command line options for AutoCAD or some of the parameters you want to pass into Inventor. Some of the other benefits we're adding in V3 are aliasing so that you can upload your app and label it as maybe beta if it's not really ready to go into production yet, while your main workflows are still using a production alias. Nicknames and sharing go together. So with V3, we'll have the ability to share apps with other people, other customers, or specific Forge apps. And because the way that Forge works today, you get a really long GUID that's really hard to use for the name. With a nickname, we give you a specific name so that you can actually share it with a human readable name. So for the Inventor apps that we're planning on publishing for other people to use, they'll say Inventor plus whatever the name of that app is. And then we've also added support to be able to cancel a work item or get progress on the work item that's actually running. So those are some of the new features coming in V3. If we look at design automation APIs for Inventor, we're targeting basically three main workflows: configure, export, and generate. And I'll walk in to some of these in detail. So if we look at the configure workflows, we're really looking at engineering automation workflows and sales automation workflows. So whether that's internal process automation or generating models or materials for sales or requests for quotes. If we look at export, we're looking at doing things like supporting other CAD formats, being able to customize some of the output options on those exports, being able to support custom drawings, maybe custom bonds, or custom interops. I think of the main difference between design automation export and model derivative is there's typically code involved. Whereas model derivative today will just take an input type and give you an output type. And then if we look at the generate workflows, we're looking at things like potential design alternatives, bucketizing things in product families, being able to do some custom model validation or possibly some business rules enforcement, or to be able to do some bulk automation or bulk operations like you've done in Task Scheduler today. So these are primary workflows we're looking at, but since you can upload and run any code on design automation, we want to make sure these workflows work smoothly, but we're not going to prevent you from doing really whatever you want to do via the API in the cloud. So if we look at some of the fine print, what can I do? You can run batch operations using the input. Like I kind of mentioned before, you have access to all the business logic of the Inventor API. So everything but the UI, you should have access to. And then you can also run iLogic scripts as well. A few things, though, that at least with V3 right away, you won't be able to do. Certainly won't be able to pause for input. So once you run the job, that job is either running or you cancel it. There's no concept of a sticky session. So within the granularity of your work item, you can run multiple apps. You can have that work item within certain limits run and get your job done, but there's no way to call back in and attach to that same worker host again. And then there won't be things like Excel or things you may already have installed on your desktop. So if your API has dependencies that may not be available on the worker host, those are some of the things you'll need to figure out before you get ready for design automation. So where are we right now? So right now we're gathering feedback from our current V2 private betas. We're just starting up a V3 private beta right now. We're trying to get some initial feedback on things like documentation. We're updating our sample apps right now. So we're looking to get this out fairly soon. If you are interested, we do have a email alias here that will go to myself and the product manager, and we'll contact you about what your workflows are and maybe what the timing is on whether it's our private beta or public beta that we'll have coming out later this year. And then really you can start refactoring your Inventor add-in today to start working as an Inventor plugin. And with that, Adam, can you still hear me?
Yeah.
Okay, great. So I wanted to walk through a quick demo. Some of you may have seen this before. Once we move to V3, we'll actually be working on a V3 demo as well. So this is running against V2. And this is taking an existing Inventor model, uploading that to Design Automation in the cloud. Inventor models use cosmetic threads. What we worked with a company called Cool Orange, who already had an add-in to take an Inventor model and model the threads. And what we'll do is upload this model into the Cool Orange's web app. They use Design Automation to then model the threads, and then we'll be able to download that model back into Inventor. So it just shows the workflow of going up to the cloud, having it run some work, and you can see the outputs here. So if we look here, you'll see this is the Inventor model with cosmetic threads. Go to the Thread Modeler website. So this is the large model viewer, the Forge viewer today that you see up here up above. We're going to upload our part. And what this does is this kicks off a job in Design Automation. We model those threads. The API comes back, and then you'll get it. The one on the left is the old model, which had the cosmetic threads, which don't show up in the large model viewer. The one on the right actually has the model threads, so you can see those in the large model viewer. So it's before and after, and then you can actually download the after. And we'll bring that back into Inventor just to show that some modeling was done on those threads. And you can actually see the features that were generated by Design Automation in the cloud. So again, this is just one of many workflows that you could do by uploading an add-in, uploading some template parts into the cloud. And I think with that, that's all I had.
Yeah, thank you, Andy. So any questions from anyone? Again, you can just type your question in the questions panel of the user interface of this webinar.
Looking through some of these now. Adam, I'm having some trouble with my